Imagine this, you book a flight, but there is no airport involved. No long runway, no driving an hour out of the city to catch your flight. You hop on a plane and it just takes off straight up from a small pad like a helipad. No. That is alien abduction. Do we have something flat like a helipad? Yeah, that's it. Now make a flight, take off straight up and then move forward like a normal aircraft. Yeah, that's it. So a flight just takes off straight up from a small pad like a helipad and then cruises like a normal aircraft. And because there is no need for giant airports or runways, the service and your tickets will be cheaper too. Sounds like science fiction, right? A team at IIT Madras is trying to make this happen. At IIT Madras in the Department of Aerospace Engineering, Professor P.A. Ramakrishna and his team have built a small test machine in their lab. It is a tricycle platform fitted with 3 rocket thrusters. Ramakrishna's team has demonstrated the feasibility of soft landing for vertical takeoff aircraft and UAVs. In one key test, their system reached a touchdown speed of about 0.66 meters per second. That's roughly like a slow step. And for a landing, it matters because if you want an aircraft to go straight up and come straight down, which is what we call vertical takeoff and landing or VTOL, you must control the speed very carefully. Too fast and you slam to the ground. Too slow and you may lose control. This team has built a rocket-powered platform that can listen to computer, adjust its thrust and land softly using air and wax-based fuel. It's a new way of thinking about takeoff and landing.
It is a tricycle platform as seen here. So we have this hybrid rocket motors at 3 locations, just like what you have in an aircraft landing gear. So these are the 3 hybrid rocket motors. This is the fuel. Hybrid rocket motors. These are the fuel blocks, and when you pass air and ignite it, it starts to balance itself out and hold that position, horizontal position. So now it can do this repeatedly. Now the challenge is to scale this up to an actual aircraft level.
So why does that matter to you? I'm getting that. Today, we mostly have 2 kinds of flying machines. Helicopters, which can go straight up and down, which makes them useful in small spaces. However, helicopters are slower and cannot travel very far and are often considered inefficient. Next, we have planes. They are very good at flying long distances at high speeds, but they require long runways to take off and land. VTOL aims to combine the advantages of both helicopters and aeroplanes. It combines helicopter-style takeoff and landing with airplane-style speed and range. You might think, why disrupt an already working runway system? Well, when you buy a flight ticket today, a large part of the cost is not just the fuel, it's the infrastructure. Runways are often 2 to 3 kilometers long, requiring massive land and expenses for pavements, lighting, safety areas, terminals, parking bays and more. If aircraft can take off vertically, long runways are not always necessary. Smaller hubs like helipads could accommodate even a reasonably big aircraft for takeoff and landing. This would enable better connectivity between smaller cities and towns and reduce waiting periods at gates. And over time, lower infrastructure costs could make flying more affordable. VTOL aircraft also have a significant role during emergencies like war. In a war, runways can be targeted and destroyed. If your aircraft can only take off from a runway, you're stuck. But if your aircraft can lift off vertically, it can operate even if the runway is damaged. Additionally, you can deploy aircraft closer to the borders and even in rough terrain.
Where does this come in very handy is, if you remember during Operation Sindoor, we hit the runway of our adversary. Now, someday somebody can do it to us also. How do we react to that situation? With this technology, we can take off without the runway requirement, and that will be a big bonus in such events.
This VTOL achievement is currently in a small-scale demonstration stage. According to the team, the current system is designed to carry roughly 40 to 50 kilograms. The goal is to lift a person along with an additional payload, maybe 80 kilograms or more, and then scale the technology up further. The next realistic step is to test the system on small fixed-wing UAVs before moving to larger civil and military platforms. To make this technology work on real aircraft, the team sees three big challenges. First, scaling up. Bigger planes are heavier, so they need more thrust, more air to act as oxidizer, and stronger structures. Second, attitude stabilization. The aircraft must stay level or correct itself if tilted. So far, only one basic motion has been tested. Third, integration. Large aircraft would need engines designed from scratch to feed air to these thrusters, so retrofitting existing aircraft is difficult.
So we are all like thinking in that direction where we are going to use gas turbine engine alone to do all the VTOL vertical takeoff and landing and the cruise flight. Instead of that, what will happen if we separate those two things? Use gas turbine engine for the cruise flight and use an additional system for vertical takeoff, which can give you much better thrust for that short duration. So that is one challenge. Like I am not saying like that is the only direction. Maybe different systems will come up, but then we'll have to think about like how you like bring it together and use it together. But this is one sort of that system we are trying to bring in. There can be another ideas also.
If it works at scale, the future VTOL aircraft you see may trace their origins to this small tricycle platform in a Chennai lab.